The public unveiling of Webb's initial photos was an astronomical milestone that demonstrated the observatory's extraordinary ability to peer into the depths of the universe. The second image shown was that of an exoplanet that we had previously attempted to examine, although with limited success. This time around, the breadth of the investigation is vastly expanded, thanks to the telescope's enchantment. Before we delve into what the observatory uncovered, let's briefly review what we already know about WASP 96B. Hello everyone, and welcome to another video. Today, we'll be looking at how the James Webb Telescope's unexpected discovery of WASP 96B shocked scientists. Yeah, you heard it right. So, let's start our video. WASP 96B is one of almost 5,000 known extrasolar planets in the Milky Way, located approximately 11,150 light-years away in the constellation Phoenix in the southern sky. It is a type of gas giant with a mass less than half of that of Jupiter and a diameter 1.2 times larger than Jupiter's. WASP 96b has a temperature of over 1,000 degrees Fahrenheit, making it significantly hotter than a pizza oven. WASP 96b orbits its sun-illuminated star at a distance of only 1/9 that between Mercury and the Sun, completing one round every 3.5 Earth days. While we're on the subject, let's examine briefly what spectroscopy is, so that astronomers can identify chemicals such as water, methane, and carbon dioxide on a faraway planet. They aim the telescope at known exoplanets in our Milky Way galaxy and then wait for the planets to pass in front of the bright stars. This starlight travels through the exoplanet's atmosphere, through space, and into spectrographs. Aboard Webb, this method is known as transit spectroscopy. Therefore, there are technically advanced prisms that split the light into a spectrum of colors. What's great about this is that the molecules such as water and the atmosphere absorb specific colors or wavelengths of light. Nestor Espinosa, an exoplanet researcher at the Space Telescope Science Institute, which operates Webb, says that each molecule has a distinct diet, and that is roughly what is occurring here. Alright, let's move on to the event's unveiling. Some of the most astounding discoveries made and to be made by the powerful Webb telescope will not consist solely of gorgeous images, although those that do will be stunning. Instead, the sensor can determine the composition of the atmospheres of extremely distant exoplanets or worlds outside our solar system. At NASA's presentation, it was disclosed that the James Webb Space Telescope has identified the unmistakable trace of water on the 150 light-years away exoplanet WASP 96b11. Although this is not the first time water molecules have been detected on another planet. The Webb telescope, constructed with a 21-foot mirror that is more than 2.5 times larger than the Hubble, provides spectacular views at faraway planets such as WASP 96b. While the Hubble Space Telescope has analyzed several exoplanet atmospheres over the previous 2 decades, 2013 marked the first definitive detection of water, according to the space agency. In the endeavor to characterize potentially habitable worlds beyond Earth, Webb's immediate and more precise observations represent a major leap forward. The telescope has confirmed the detection of a distant water signature, as well as evidence for the clouds and haze in the atmosphere around a hot, puffy gas giant planet orbiting a distant sun. The finding, which confirms the presence of certain gas molecules based on minute dips in the brightness of specific hues of light, is the most thorough to date, once again confirming Webb's unparalleled capacity to investigate atmospheres hundreds or thousands of light-years away. While the Hubble telescope has analyzed a significant number of exoplanet atmospheres over the past 2 decades, including catching the first clear detection of water in 2013, the Hubble telescope has yet to identify a planet with an atmosphere that contains water. Webb's immediate and more comprehensive observation represents a quantum leap in the quest for potentially habitable planets beyond Earth. The combination of a big size, a short orbital peer area, a puffy atmosphere, and the absence of neighboring objects emitting contaminated light makes WASP 96b a greater target for atmospheric investigations. On June 21, 2022, the Webb's near-infrared imager and slotless spectrograph or nervous instrument measured light from the WASP 96b system for 6.4 hours as the planet traversed the star. It resulted in a light curve depicting the overall dimming of starlight during the transit, and a transmission spectrum displaying the brightness shift of distinct infrared light wavelengths between 0.6 and 2.8 microns. While the light curve validates aspects of the planet that had previously been discovered through other observations by earlier telescopes, such as the planet's existence, size, and orbit, the light curve itself provides new information. Webb's transmission spectrum reveals previously concealed elements of the atmosphere, such as the unmistakable signature of water, signs of haze, and evidence of clouds that were previously assumed to be non-existent. A transmission spectrum is generated by comparing starlight filtered by a planet's atmosphere as it traverses a star to unfiltered starlight detected when the planet is adjacent to the star. Based on the absorption pattern, scientists may detect and estimate the abundance of essential gases on a planet's atmosphere. On the graph, the locations and heights have peaked. Similar to how individuals have unique fingerprints and DNA sequences, atoms and molecules have characteristic patterns of wavelengths that they absorb. The spectrum of WASP 96B, captured by Nereus, is the most detailed near-infrared transmission spectrum of an exoplanet and atmosphere captured to date, but it also encompasses a remarkable variety of wavelengths, including visible red light and a section of the spectrum that no other telescope had previously accessed. Greater than 1.6 microns in length, this portion of the spectrum is very sensitive to water and other important chemicals, including oxygen, methane, and carbon monoxide, which are not immediately apparent in the spectra of WASP 96B, but should be observable on other exoplanets slated for Webb investigation. What do you think of the Webb-provided information on WASP 96B? What other exoplanets exist in the universe? Do you wish to view Webb-based research? Let me know in the comments section down below. I hope that you found this video interesting, and if you want to see more videos like this, please consider subscribing to my channel. See you in the following video with some more of the latest updates, and until then, stay tuned.